Welcome to today's session. In today's session, we will observe the phase modulation. We will discuss about phase modulation. Phase modulation is defined actually the process of varying the phase of the carrier signal in accordance with the instantaneous value of the modulating signal. As we know, we are representing our message signal with x of t and the carrier signal c of t. Now, consider the carrier signal c of t, which is known as AC cos omega ct. Then, the phase signal can be represented as phase omega I of t equals to omega ct plus kp into m of t, where kp is the phase sensitivity factor and m of t is our message signal. M of t represents the message signal. So, it is as the actual modulated signal S of t, usually we will represent, equals to AC cos of psi of t. This psi of t is where here the phase will vary, so carrier signal omega ct plus kp into m of t. So if you substitute this particular equation here, then we will be getting the modulated equation of PM, that is phase modulation, where phase of the carrier signal will be varied with respect to instantaneous variation of input message signal. So the equation representation, modulated equation representation of PM will equals to AC cos of omega ct plus kp into m of t, where kp represents the phase sensitivity term. Then coming to phase modulation, deviation in PM. So we can represent like this, that is nothing but where omega I equals to, we know that derivation of psi I of t, so that d by dt of omega ct plus kp of m of t. So here omega c will be as it is, for t it is 1, so omega c, if you derivation this plus kp into d by dt of m of t. We all know that derivation of this m of t kp into m of t is nothing but del omega. So omega c plus del omega, we will see omega del omega is nothing but, we know that it is frequency deviation. Okay, so it is nothing but kp into d by dt of m of t. We all know that we have a relation between frequency and phase modulation, as the relation between frequency and phase modulation is nothing but we can achieve FM from PM and vice versa, PM from FM, by using simple integrator and as well as differentiator. So how can we achieve frequency modulation by using our phase modulator? Means by integrating we can observe phase modulator, and by differentiating the FM we can achieve PM. So there is a relation between FM and PM, as by using integrator and differentiator we can achieve FM and as well as PM, vice versa. All these things already we discussed related to FM. Coming to the bandwidth of FM, we have a defined bandwidth like Carson's, one scientist, he have given the bandwidth of FM. He states that actually bandwidth of FM will equals to 2 FM into number of significant sidebands. So according to Carson's rule, he states that the bandwidth of FM will equals to twice the summation of frequency deviation and as well as highest modulating frequency. So that it will equals to 2 into del f frequency deviation, that is twice we are telling, so 2 into del f plus fm, maximum frequency. So this one is actual Carson's rule bandwidth of fm. Then we will see some of the differences between am, fm. So we have discussed in our previous session amplitude modulation and frequency modulation. As coming to the differences between amplitude modulation and frequency modulation. Here, first of all, the parameter we goes for the definition. If it is amplitude modulation, amplitude of the carrier will be varied. If it is frequency modulation, the frequency of the carrier will be varied. Coming to parameters like frequency and phase, here in amplitude modulation, the constant parameters will be frequency and phase. In frequency modulation, amplitude and phase. Then observe the waveforms of AM and as well as these are the waveforms of FM. Modulation index we know, and number of sidebands here in AM only 2, but it depends upon modulation index here. Bandwidth 2 FM and 2 into delta F plus FM here. Applications coming to here, microwave and band broadcasting, video transmission in TV. It is also broadcasting FM and audio transmission in TV we can use. These are the applications and some of the comparisons between AM and FM. In the next sessions, we will be seeing some more. Thank you. Thank you for listening me.